So let's try to run this. Just we are already built. So circle radius is this, square side is this, and rectangle sides are 10 and 20, as it was probably expected. Now I will get into the business of constructors next week, and this will be an interesting, thing to revisit. So right now, don't worry about constructors. Intuitively, you should realize that circle maintains its radius in memory. I give it 35. Square contains its side in memory. I give it 15. Now the rectangle contains the two sides, one that it inherits from the square, because I decided to reuse square as the keeper of the side, of one of the sides, and the second side, rectangle adds to the picture, because it says, okay, I will also have the second side. Now I don't have circle on this UML diagram, but you get the idea, right? Like I said, square keeps track of its side. Rectangle keeps track of its side as well. So when I run it, I get my expected outputs, right? So I get my outputs right here. But question, how useful is my design so far? Well, number one, yes, I am pretty proud that I can create a circle, a square, and a rectangle, and then each individual shape I tell, hey, go ahead and draw itself. But what if I wanted to create 3 circles, 2 rectangles, and something else, but then dynamically delete 1 circle and add 10 more squares? Do I have to rewrite my code every time? It's a severe limitation right now. I feel like I cannot really do anything. Yeah, I can statically display 3 shapes. First I need to create them by the new operator, and then I can display them by saying draw, and it all works. I can test it right here. Well, it seems all to work. But the problem is, right? The problem is that how can I make it much more flexible? That maybe I can ask a user how many circles you want to create, and they'll say 5, right? So what do I do then? How do I manage all this? So here's the possibility. Here's the possibility. Number one possibility is that we create another class. Interface demo package. Go ahead and create a new Java class, and we'll name it shape. Well, that sounds interesting, because each one of them is a shape. So I'm sort of beginning to think in that direction. All right, create a brand new class, named shape, and do something really strange now, saying public abstract void draw. No parameters. It looks like a method, but I'm naming it abstract. And then I also use a semicolon at the end to say that, well, you know what? Each single shape which will be able to take advantage of this class shape should be able to provide concrete implementation of this abstract method draw that I'm just declaring but not defining. Unfortunately, there's one extra piece that I need to do, and that is, once you add abstract method to a class, you have to declare the entire class abstract. I don't know exactly why technically Java requires you to do that, but you can read about it. There is an explanation in the manual why this is a requirement. So I have my class shape. Make no mistake, it's one little class, which is just a little technicality, which is now provides an interface which includes this operation, right? Named draw. And draw should be a common operation for every shape. Now I go into my classes and say square. or actually, let's start with the circle because circle was the first one we created. We can say circle extends shape. Just this, that now circle extends shape. Now let's picture it. So I have a class named shape. It has abstract method draw. I will use like quotes around the name of the method. Method draw, right? No attributes and quote unquote draw. So that draw is abstract. Then I also have a circle, another class that I have, and it does implement draw. That's good. And it has this private radius that it maintains, right? That's what I have. Oops. Let me switch to select, delete this unnecessary shape. And when I say, let me actually move it so that we can see all of this somewhat. As you can see, now I say circle extends shape. What it means is that I created inheritance from, from shape to circle, and it, in other words, it means circle is a shape. That's what it really, the most formal definition of it is. All right. So circle is a shape. Shape declares an interface. That interface includes the draw. It's an abstract a method named draw. I use quotes here in my diagram, but here it says abstract, and instead of opening a brace and closing the brace, it's using the semicolon. It says, hey, listen, anyone who wants to use shape interface, because I'm declaring those abstract operations, they must provide a concrete implementation of the draw. In fact, no changes took place in circle other than saying, oh, let's like extend the shape, because circle is really a kind of a shape. Similarly, take extend shape and go to square and say, hey, square, you actually are extending a shape. Which means that now on our UML diagram, what happens is that we create new relationship and saying, hey, the square right here, square also is a kind of shape, right? So square extends shape, circle also extends shape. Now rectangle doesn't need any change because it already says I'm extending square. So it says, rectangle says whatever square is, however square defines itself, I am it, right? So therefore no extra changes on the diagram are required. So this is what I have right now on the diagram, and mimicking this design in the code. Now going now to the main method. So here's now what I can do. Here's this trick that I can now do to make it flexible. This is like hard-coded drawing, right? But I want flexible drawing. You probably sense it that somehow I'm going to take an advantage of the fact that I have now shape on top of everything. And shape tells me that you can draw these shapes. Well, guess what's going to happen? I can create something that's called shape. Well, I guess I'll use an array of shapes. Shapes, right here, shapes equals new shapes. And I'll say I want to use 3 shapes. Syntax. Okay. Why am I saying shapes if it's just a shape? Okay, fix that. All right. So what I just did is that let me take I'll just new, okay, and don't save. So now this is what happens. I've created, just looking at this code, I've created an instance. I've created an instance of a circle. And when I say instance, you know how I like to draw 3D boxes. Let me start over. Just didn't do it very clearly, so let me start over. So here's a little box that sits in memory, okay? Trying to be more careful. And it has this radius inside, right? The radius. Now again, I'm not very good at trying to use my mouse doing the writing. But this is the circle, and it's named circle. Now I have a variable named circle that basically, this little circle variable, right? It gives me access to this object in memory. So this is called a reference. This is an actual object. The object is created by the new operator. More so, circle remembers 35 as its radius. So it actually stores value 35 inside this box. Then I create a square, right? Square is a little reference that is also capable of, you know, keeping track of another box, right? So it's slightly different. It came from the class named square, and it contains the side, right? Side, and of course the side remembers that its side is 15, so 15 is remembered right here. And I create a rectangle, rec, right? So this another little reference variable gives me access to a slightly different box, and it's actually a little bigger box. What this box contains inside is actually this type of object, the square. Why? Because I say right here, in the definition of the rectangle class, I say that rectangle is a square, which is unfortunately not the right thing to say, but the programming language doesn't know, so I can get away from it, you know, with it. So what happens here is this: when I look at the memory picture of this, this square is really an inherent part of rectangle. So it's right here inside the rectangle. That's where a square is created as soon as a rectangle is created. So it has its own side, right? This is really the true thing that's what's happening in memory. And so there's also side 2, which is defined right here in the rectangle. And my rectangle keeps track of this object in memory.